All right, we're on page 362. This is the last lesson in this module and in this topic. We're working on lesson 5, and we're skipping activity 1, only focus on activity 2. Activity 2, we're going to be going through some problems, and there's going to be others for you to's. And then we'll get to, at the end, talk the talk, solving systems by substitution. And then toward the end, there will be an assignment. So quite a bit of stuff for this video, but we're going to get started on number 1. So we're all dealing with contexts, story problems, writing the equations in the system, and then separately trying to solve and then interpret the answers for those scenarios. So this is the very, very last lesson on systems. Okay, so the context we have, it says the admissions fee for the fair includes parking, admission rides, and admission to all commercial and agricultural and judging exhibits. The cost for general admission is $7. Let's highlight that. The price for children under the age of 5 is $4. And then we also have how many people attended. There are 449 people who attended the fair on Thursday, and the admissions fees collected amounted to over $2,000. Okay, so there's certain equations that we can write. So first of all, for A, it says write a system of equations in standard form. Standard form, right? If you're not sure, it looks like this. It's ax plus by equal to c, where a, b, and c are capital, and a, b, and c are typically just numbers, like whole numbers in this case. So it says use x to represent a number of people 5 and over, and y to represent number of children right under the age of 5. So what we can say is we're just gonna say x is adults, y is children, although it doesn't quite amount to that, but just for simplicity's sake. So you can write an equation for a number of people. The people over the age of 5, x, plus the people under 5, y, is the total amount of people that attended, which is 449. And then separately from there, we can also write this in terms of how much each group paid. So this one is in terms of money. So the first equation, people. Second one, money. We could have 7x be the term in the second equation. This is $7 for all the people that paid, that were over the age of 5. And then, right, it's slightly cheaper for, not 5. For y, it's $4 for people that are under 5. And if you add all that up, the revenue generated is $2,768. Okay. So B, before we actually try to get to solve this equation, it says without solving these systems of linear equation, interpret the meaning of the solution in terms of this situation. So the solution of this linear system will give the number of people 5 and over, and the number of children right that are less than 5. So how many people attended? We'll just say younger than 5 years old. I'll just abbreviate. And over 5 years old that attended. Right, this fair. So we're looking for two things, right? We're looking for what the value of x is and what the value for y is. So when you're trying to solve a system, you got to figure out both. So we're going to get some big numbers here. So I'm going to take this first equation and I'm going to solve for, right, we can either solve for x or solve for y. For this one, I'm just going to solve for y. If I solve for y, I have to subtract x to both sides. I'm not going to show that step. I'm just going to rewrite it. We're going to have y equal to, if I subtract x to both sides, because it's positive, we're going to have negative x plus 449. I'm going to rewrite the other equation as is. I like to write it side by side if we're using the substitution method. I'm going to take what y is equal to, this stuff, and I'm going to plug that wherever I see a y. Right, there is going to be a lot of computation, but we're going to try to do each part right step by step. So 7x plus 4, and instead of y, I'm going to plug in parentheses negative x plus 449. And then if I'm going a little bit too fast, just pause here so you can rewrite. A key thing here, when we have a number next to parentheses, you have to use the distributive property, which says we multiply that 4 to everything. So we're going to have 7x, and then positive 4 times a negative x is a negative 4x. You could put plus negative 4x, but I'm just going to put minus 4x. 4 times 449. You can use a calculator here, but this will be positive. I'll just give it to you, is 1,796. And then here, right, when we solve the equation, we do want to make things simpler. So we want to combine some like terms, right? 7x minus 4x, 7 bananas minus 4 bananas is 3 bananas. I'll rewrite all the numbers here. And the next thing you'd have to do, you'd have to subtract this 1,796 to both sides. I'm not going to show that step, but if you do that, you would get that this is equal to, right, 2,768 minus this number is 972. And then at this step, right, we're multiplying by 3, divide both sides by 3, you would get x equal to, right, if you divide this by 3, it is 324. Right, so this is if we subtracted, this 1700 number. This is if we divided both sides by 3. So we have a value for x, good. So the value for x, right, this is people that are over 5. And now we got to find the value for y. So we're going to substitute this back into the solved equation for x. So let's rewrite this. This will be y equal to, it's negative, and then we have 324 plus 449. So that means that this whole thing is negative. They're different signs, so we have to subtract. If you subtract, you'll get y equal to 125. So our final answer as an ordered pair, x comma y, is 324 comma 125. But this does say interpret the solution. So we do have to write a sentence here. We're going to say that there are 324 people 5 and over. I'll put comma, and 125 children under the age of 5. Okay. That attended the fair on, this day, Thursday. Okay, so that's pretty much it. So, right, it does take some effort to write an equation. We have to think about, right, what are the things that are being represented? And that's why we highlight, right? So we have, right, money that's represented. We have people that attended that's represented. And that's what we wrote, right? This is people and this is money. All right. So we used that, we solved it, and we found the value for x and y of answering the types of people that attended. Okay. All right. So the next page 263, this is a UDO. So this is dealing with dealing with revenue, dealing with seats. So you're welcome to try to kind of copy what we did in the previous problem to solve this. Right. Although, right, not exactly the same context or the same numbers, but just see what you can do. So pause it here. We're going to move on to 364 right here that deals with Miss Rose. Okay, so there's a total of 4 problems, 4 different situations. We went over the first one. The second one is a UDO. Third one we're going to do together, and then the fourth one will be another UDO. So, right, it's one thing to just listen to me and write down, but it's another thing to practice. Let's make sure that we're practicing. All right, so this says, Miss Rose told her class that tomorrow's math test will have 20 questions and be worth 100 points. And the multiple choice questions vary in points, so they're 3 points each. And the open-ended response questions are 8 points each. And it says determine how many multiple choice and open response questions are on the test. So we don't know the amount. We can figure that out. So with this, it says write a system, and the previous one we already had the variables defined. This one we have to define it. So we're going to have a value for x and y. It does not matter which one you put as long as it represents some type of unknown. So what's an unknown in this situation? We'll have X represents the number of multiple choice questions, and Y represents the number of open-ended responses. We'll just say open. What does it say open-ended? Yeah, I'll put Q's for questions. All right. So in this situation, we know point value. We know how many problems are on the test. So if you take all of the X's and all the Y's, so all the multiple choice and open-ended responses, you get total number of questions, which is 20. There's 20 problems on this test. And then separately, right, let's also configure the point values for each type, right? For each multiple choice, it's 3 points, so it's 3x. For each open-ended response, it's 8 points, so 8y. And then if you take those and you figure out the total amount of points, it is 100 points for the entire test. Okay. So from that, great, we have that. Our solution, what is it going to represent? This is going to represent the number of each type of, we'll say, test question. Okay, great. So remember, we need one of these equations solved for. The second equation, no x or y is not does not have a coefficient of 1, right? But we do have for the first one. You can see how we can solve for x, we can solve for y. And you know what? Just for consistency's sake, I'll solve for y. So I'd have to subtract x to both sides, right? We need this solved for. So instead of x plus y equal to 20, we'll subtract x to both sides. So we'll have y equal to, we'll put minus x plus 20. And then again, let's rewrite this second equation. I'll put it horizontally. And same thing like the last problem, right? We have y. That's equal to negative x plus 20. We'll plug that wherever we see a y. So this is 3x plus 8 times negative x plus 20 equal to 100. If you remember from the last one, we had to distribute. So we'll still keep the 3x. Positive 8 times negative x, negative 8x. Positive 8 times positive 20. You could do some scratch work, but this is positive 160 equal to 100. All right. Right, so it's exactly the same problem. It's just we have different numbers here. We're going to combine like terms. 3 minus 8 is negative 5. X. And you know what? At this step, I'm also going to subtract 160 to both sides. If I subtract 160 here, we'll have this equal to 100 minus 160 is negative 60. And then we'll divide both sides by negative 5. Negative divided by negative is a positive, and 5 can go into 60 12 times. All right, so we have the value for x, which represented number of multiple choice questions, which is 12. So there's 12 multiple choice questions. We know that the whole thing is 20 problems, so 12 of them are multiple choice. That means that, right, 8 of them have to be open-ended. So, right, 12 plus 8 equals 20. All right, great. We'll write this as a final answer of 12 comma 8. We'll box this. Let's just write a sentence because we do have to interpret our solution. There are 12 multiple choice questions and 8 open-ended response questions. All right, great. And that's pretty much it. We could have plugged x in here, but we just did it mentally to find y. All right, moving on to page, this is the last one on activity 2. You're welcome to try to figure out page 365, right, writing the system, and then trying to solve it separately. And then ask me questions if you want me to verify your answer. But we're going to move on, though, from here. We're going to go on to talk the talk. So we're going to be reviewing for our test pretty soon for this module. So we're going to do number 1, A and B as practice. You're welcome to do B and C as a you do. But let's go and get started here. So this, we don't have to write the system. It's already written for us. And it's actually, this one at least is solved for us. So we're just going to now just solve via substitution. This is our last substitution practice that we have together. We'll take what y is equal to, which is 5x, and we'll plug that wherever we see a y in the other equation. So instead of 2x plus 3y, it's 2x plus 3, and then a 5x in parentheses. All right. This we can simplify by multiplying it. So we're going to get 3 times 5x, which is 15x. If we combine 2x plus 15x, those are like terms. I'll highlight this. 2 bananas plus 15 bananas is 17 bananas equal to 34. If you divide both sides by 17, right, I won't always show this step, but to perform the inverse operation, 17 can go into 34 twice. All right, and when you have 1, you substitute to either equation. I always choose the solved equation, so this one here, because that'll find the value of y. So if I rewrite this equation, y equal to 5x, that's where I take x equal to 2 and I plug it in there. So this will be y equal to, instead of 5x, it's 5 times 2. And 5 times 2 is not too bad, right? It's just 10. So our final answer here is 2, 10. Now, this problem does say to check your answer. So how do we check our answer? You check your answer by plugging it into the equation, any equation really. We already plugged into the second one, but we can plug this into the first one. If I take my value for x and y, let's say we're done with the test, we're not sure if it's right, we plug it in. So instead of 2x, I'll put 2 and x is 2. Instead of 3y, I'll put 3 and I'll plug in a 10 because y is 10. And this is all equal to 34. So I'm rewriting this first equation, but plugging this in. 2 times 2 is 4. 3 times 10 is 30. Right, and it's true that 4 plus 30 is 34. We have a true statement. Actually, we should have a true statement where that number is equal to itself. Okay, so that's how you check your answer. We're going to work on B, which is slightly different, but we can solve one of these equations. So you can see here we can't substitute because none of these are solved for. We don't have x equal to or y equal to. But I do see in the first one, right, y is by itself. There's no, well, when I say by itself, I mean that there's no number in front of it. But we can solve that easily by subtracting 3x to both sides. Okay, so if we do that, this equation will be y equal to negative 3x, and we have that 8 already on the right side, so plus 8. Now we'll plug this in for y in the other equation. So we have 6x plus 2, and instead of y, it's equal to negative 3x plus 8. That's all equal to 10. Right, this might seem like deja vu because we're applying the same exact steps, right? We're just using the distributive property. So 2 times negative 3x, that's a negative 6x. 2 times 8 is 16. And then this is all equal to 10. And just like the last one, we do have to combine like terms. And you may notice 6x minus 6x, I'm going to circle it because that is equal to 0. We're left with just 16 equal to 10. No more variables, no more x's. We have talked about these special solutions. The special solutions are either no solution or infinitely many solutions. So it depends when after the variables cancel what type of statement you have. You may see that 16 is equal to 10 since it is a false statement. Across, it is not equal to. False statements mean that it is no solution. It is not possible to have a value for x and y that satisfy the equation. If we did have a true statement, I'm just going to give something off to the side, like 5 equal to 5, then that is infinitely many solutions. I don't know why I put a period there. All right, anyways. All right, so that's going to conclude Activity 2 and Talk the Talk. You're welcome to do the other problems as you do, but let's go and skip a couple of pages. This was part of Activity 1, which we did not do. This is a blank page. Our assignments. So our assignment here, not too many problems. I'd like for you to do page 369 here. And you're doing the front side, which is 1a through c, and then 2a on the back side. So number one, this is saying you're going to take this thing here and set every expression equal to that. Minus the first expression. I just wanted to make something a little bit simpler, so I made this 5x plus 6, and you're going to set this equal to, right, just write what we have in the problem for each one. This one will do the same thing, right? 2 times x minus 1 plus x equal to, and then write the same exact thing. That's what you're doing here. And you're just going to solve each one for x, and I'll let you write that one. And then figure out what the solution is. And then on the backside is, we only have one problem for substitution. We're just doing number 2a. You don't have to do b, you don't have to do c, or the other problems. Okay, so it's just 4 problems total. Let me know if you have any questions.